Hello, I'm Matthew, and today we'll talk about similar triangles. First, what does it even mean for triangles to be similar? Well, triangles are similar when they have the same shape but have different sizes. The triangles still could be flipped or turned around, but as long as they maintain the same shape, they will be similar triangles. There are three rules that tell us when the triangles are similar. The first rule is called the angle rule, also known as AAA. If the three interior angles of the triangles are the same, then the two triangles are similar. This is also known as AA rule, and I'll explain why soon. The second rule is called side rule, also known as SSS. If all three sides of the two triangles have the same ratio, then the triangles are similar. The third rule is called side rule, SAS. If the two sides of the triangle have the same ratio and the included angle is the same, then the triangles are similar. Let me show you some examples of them. This is an example of the AAA rule. Here we have two triangles and all three angles of the first triangle are the same with the three angles of the other triangle. You'll see that here we have 40 degrees and we have 40 degrees here. We have 65 and we have 65, 75 and 75. So all three angles of the triangles are the same. So therefore they have the same shape, meaning that they are similar triangles. In mathematical notation, this is written as triangle ABC is similar to the triangle DEF. And this rule is also called AA rule because when the two angles of the triangles are the same, the third angles will always be the same as well. If you look at this example, the two triangles have two matching angles. We have 40 and 40 and 65 and 65. So two of the angles are the same. And if we do the calculation for the last angle, because the sum of all three angles of a triangle is 180 degrees, so the last angle would be 180 minus 40 minus 65, and you'll find that this is 75 degrees. And likewise, for this angle here as well, we have the same equation, 180 degrees minus 40 minus 65, and that is equal to 75 degrees. And you'll see that this angle, angle C, is same as angle D. So when you have two angles of the triangles are the same, the third is always the same as well. And that's why, in practical sense, we don't need to confirm all three angles. If we have two of the angles are the same, then they are similar triangles. And this is the example for the SSS rule. When the two triangles have the same ratio for all three corresponding sides, they are similar triangles. If you look at the two triangles on the screen, you can see that all three sides of the triangles are given. So we can set up our ratio equation to check their similarity. So first, let's line them up from the smallest to the largest. So for the triangle ABC, this is the shortest, and this is the next longest, and this is the longest. For the triangle on the right side, this is the shortest, this is the next longest, and this is the longest. So we match them and see the ratio between the two triangles. So our ratio equation will be side BC over side DE, because they are the shortest, and they must be equal to side AB over EF, and that should also be equal to AC over DF. And all of these should be equal if they are similar triangles. So let's plug in our numbers. Side BC is 4 centimeters over side DE is 8. And that should be equal to side AB is equal to 7 over side EF, which is 14. And lastly, side AC is 8 and side DF is 16. We simplify the fractions. You will see that this can be reduced to 1 over 2. That can be reduced as 1 over 2. And that can be reduced to 1 over 2. So they are all equal. So that means because all three sides have the same ratio, triangle ABC is similar to the triangle DEF. And lastly, this is the example for SAS rule. Given that you have a matching angle, 40 and 40, and now we just have to compare the two sides that include the angle, 7 and 8, and here it'll be 14 and 16. So we match the shorter sides AB with the shorter sides of the other triangle EF, and that must be equal to AC over DF if they are similar triangles. Let's plug in our numbers and we'll see that 7 over 14 is equal to 8 over 16. This can be simplified to 1 over 2, and that could be simplified to 1 over 2. So they are the same. And by the SAS rule, the triangle ABC is similar to triangle DEF. I hope you found this video helpful. If you did, please hit the like button and subscribe. I'm Matthew, and I'll see you in the next video. Bye!